Good day, everyone. Today, I'm going to teach you about the limit of a function. But first, let's define the limit of a function.
Let f be a function defined at every number in some open interval containing a, except possibly at the number a itself. The limit of f of x as x approaches a is L, written as the limit of f of x as x approaches a is equals to L. So, we can determine if our limits are existing if we had followed these two conditions. So, the limit of a function as x approaches a exists if our f of a is defined, or f of x approaches the same value as x moves closer to a from both directions. So, in this video, I will going to teach you about one-sided limits and the two-sided limits briefly. But first, let's go ahead to one-sided limits.
When we say one-sided limits, these are limits that exist only through x values on the right of a or any on the left of a. Remember that these one-sided limits will either be working as x approaches a from the right or x approaches a from the left. And these following symbols, the plus sign and minus sign, will give us clue whether we're working on the right-hand limit or the left-hand limit. Did you understand? If you do, let's try out some examples.
If you're tasked to find the limit of x squared minus 9 over x minus 3 as x approaches 3 from the right, so when it comes to computing a limit like this, one of the first thing you want to check is to see if there are any problems at the value. And actually, for this one, we got a big problem. If you try and use 3 directly, notice on how you get a 0 on the bottom of your function here. Now, of course, we can't divide by 0, so a direct substitution is simply not going to work. There might be instances where you might be able to simplify this into something just a little bit better. In fact, notice on how the top actually factors, so we're going to break that down.
I like hot
So
dog
we have
because I do not a dog. Do you like hot dog? I like hot dog because I do not a dog. Do you like hot dog?
That's important because we can actually cancel out the extra factor, which is x minus 3, and from our numerator, x minus 3. Of course, one of the reasons, the biggest reasons why we can cancel this out is because we are talking about limits and x does not equal 3. We're simply getting really close to 3. So now, we can evaluate our limit. So, we can use direct substitution in this one. So if we're going to this one, we have 3 plus 3 will equal to be 6. So this is the final answer.
And now, we are done with one-sided limits. Let's discuss two-sided limits. Two-sided limits has two components, the left-hand limits and the right-hand limits. Left-hand limits, notice that as our x approaches a from the left, our x is less than a. On the other hand, in the right-hand limits, notice that as our x approaches a from the right, our x is greater than a. So, let's work with an example. If you are given this kind of function, the limit of 1 plus 3x as x approaches 2, so we know we'll approach it from the left and from the right. So let's start it from the left-hand limit.
I like hot dog because I do not a dog. Do you like hot dog? Eat hot dog.
So in this kind of function, we can substitute 2 to x. So we have
I like hot dog because I do not a dog. Do you like hot dog?
and now let's evaluate our right-hand limit.
I like hot dog because I do not a dog. Do you like hot dog? I like hot dog because I do not a dog.